Okay, hello everybody. My name is Sam Bjornstead. I'm going to talk about USB malware and specifically bad USB. Some research that was done a couple years ago on USB malware. My background um, is initially programming. I programmed a while for some banks in Sioux Falls and a little bit for the Landsat mission for USGS. I moved to Minnesota in 2010 and did some system administration work and teaching for the computer science department in St. Mary's University in Minnesota. And I taught mostly 100 level classes, a couple 200, 300 level. And then finally, I was a signal officer in the South Dakota Guard for about 13 years. And as a signal officer, I was responsible for setting up networks um, and worrying about the security of those networks in the battalion. I was also a company commander where I kind of did the exact same thing. Um, and so part of the interest for USB security comes from that. In somewhere around 2008, the DoD outlawed all USB drives. We couldn't use them to transfer files or anything anymore on all DoD computers, which turned into a huge headache because all of a sudden we're writing CDs and distributing things that way, which was interesting to say the least. So they didn't ever tell us why they did that, and so I thought that was an interesting place to start some research. So why USB malware? Obviously, we all know USB is everywhere, and it can be an extremely easy attack vector. The social engineering side is you drop a USB stick, and somebody's probably going to pick that USB stick up and plug it in their computer at some time. I think it would be very interesting to do a study on that. I don't know that it would ever pass an IRB approval, but to see out of 100 USB sticks that you dropped, how many get picked up and plugged in and things like that. So I think that would be very interesting, but it's probably not very ethical, maybe. But I guess the drawbacks for USB malware is you have to be in the local area. I can't attack somebody in California or the East Coast from South Dakota using a USB attack. So USB attack history, basically you have your typical infected file that would get caught by antivirus now. That's not really used very much anymore. Auto-run files, which kind of got shut down by Windows a couple years ago when things didn't automatically run as soon as a USB stick was plugged in. Social engineered ClickMe or more X-rated versions of ClickMe probably still work fairly well. And then sometime around 2009, Stuxnet appeared. And it took a while for us to hear about it in the public, but that was a USB-driven attack using four zero-day exploits, but primarily USB-driven and then spread that way. And then bad USB, which was developed or was presented in 2014 at Black Hat. So we'll talk primarily about bad USB because it's pretty interesting. So it's developed by Carsten Knoll and Jacob Lell from Security Research Labs in Germany. And the premise is they modify the firmware of USB devices so that a USB device, once plugged in, can act as, if it's a USB drive, can act as a keyboard or Ethernet adapter or any other thing, any other USB device, really. There's no checks on that firmware, so it can say it is whatever it wants to be. Another very interesting part of bad USB is it can spread from a USB stick to the computer and then from the computer to a USB stick. So once you infect the first computer, anything attached to that computer, USB-wise, can then be infected. Since it's in the firmware, malware scanners are useless because they don't inspect the firmware of a USB device. And then finally, what's another very interesting thing is it gives you the potential for a VMware breakout, where you use a USB peripheral connected to a VM, connected to a virtual machine, can then spawn a second device on its own that connects to the VM host. So those are all of those things make this a very powerful and dangerous attack. Bad USB is platform agnostic. It doesn't really care what it's running on or where it's running. It can run on Windows. It can run on Linux. At the time of their presentation, they were only able to use the Python chips just because that's what they'd had reverse engineered for the firmware. But given enough time and development work, pretty much any USB chip can be reverse engineered, modify the firmware, and run bad USB. But it can run on Windows, it can run on Linux, it can run, again, after that time frame, or after that development work, it can run on pretty much anything that you can plug in. And so they go to a lot of work in their their presentation, which is in my references, and I recommend everybody watches, about talking about reverse engineering their USB stick. And they say even simpler than this is to use your Android phone. It's the easiest USB attack platform. All you have to do is basically say, hey, can I plug in my phone to charge on your laptop, and you've got access. So some possible attack vectors using USB, bad USB, are to emulate the keyboard, spoof the network card. Those are both shown in the presentation. Then some other ones that they kind of assume will work, or think will work, are USB boot sector viruses. You can hide data on that external storage instead of deleting it, just hide it. Rewriting data in flight, so after the initial virus scan, add viruses to a document and then store them, or update the PC BIOS. One of the big problems with this type of attack is we all assume that we're going to be infected at some point. We take precautions against infection, whether it's backups or whatever. But with this USB attack, the bigger problem is persistence. So once your machine is infected, and then everything that you plugged into your machine could potentially be infected, and you don't really have any way to know if it is or not, if you get this sort of attack, your only option at that point is to get rid of everything. You can maybe save your machine, but every other USB device you have, all of those things are going to have to be replaced, because you can't necessarily tell if they've been compromised without plugging them in, which could re-compromise your machine, and so on. So the persistence of this attack is huge, and it kind of changes the way you do everything. Mitigation is another huge problem. At this time, the only 100% solution is to disable USB at the hardware level. So we can't just turn it off in the BIOS, because you could BIOS flash and get that back on and turn USB ports back on. So if we cut the wire or fill your USB ports up with cement or something like that, that's a possibility to stop this type of attack, but obviously that's not a very logical response. So we can turn off ports in BIOS. That will stop some of it, but if your bad USB attack flashes the BIOS and turns things back on, then that's not going to work. Recommended by the developers is to lock the firmware, so that once firmware ships on a USB stick or whatever, it's locked, and if it ever gets flashed or rewritten, it won't work anymore. That's what they recommend. It's not easily adoptable by everybody that's out there. It stops us, people that like to tinker a little bit, from being able to do that, and it doesn't fix the billions of USB devices that are already out there. So that's maybe not a great approach, but it's probably the most logical at this point. Some other options are cryptographic code signing, which is similar to what Bluetooth does, to say, hey, I'm a USB keyboard, and then everybody knows that that's what it is, and it can't change. But again, it's not easily adoptable to every manufacturer and everything that's already out there. And then my last slide my second to last slide is kind of interesting. It's how much do we trust the devices that we plug into our computer? For most of us in this class, obviously we don't trust the USB stick we found in the hallway. But do we trust our friends to plug in a USB stick that maybe they found in the hallway and didn't tell us about? And then we kind of go down the list. Do we trust American-made devices? Do we trust foreign-made devices? Do we trust the cheap knockoff devices that we got for $1 from eBay or whatever? And then I guess, how far do we go to put on that tinfoil hat and just never trust anything anywhere? So that's the end of my presentation. I'm sorry I talked really fast trying to get everything in, and it was kind of a high level. In the future, I hope to use this, try and get a USB device working like this, and play with it in the lab a little bit. Thank you very much. Bye.